Hello students. So our last topic is standard template library. In this lecture, we will study the basics of standard template library. St- Now, what do you understand by its name? Standard template library. Standard means where you have used standard in C++ program, you have used using namespace std, means that standard namespace will have certain libraries that you can directly use. Like in C, you can directly use printf function from the library. But here in the previous topic we have studied templates. So some class templates have already been made. So and with that class templates we can use different algorithm functions so that we can reduce our task. Let us suppose you want to sort an array. So you can directly use sort function to sort an array. STL is widely used in industry. So like the most famous STL is like vector, which we will study, but it's only a basic course in your syllabus, so we will stick to that only. So let us start. STL provide general purpose class and functions to implement commonly used algorithms and data structures like vectors, lists, queues, and stacks. Means STL is generally used to implement data structures. What kind of data structures? Like you may have studied stacks. There is a STL called stack arrays. There is an STL called array vectors is a new concept for you that we will learn. List is a linked list is a commonly used data structure that can be implemented, that has been implemented in STL. Queues are STL called DQ is already there in STL that we can directly use, but in your syllabus only vector is in your syllabus among these. So STL has three components. First one is containers. Now what are containers? Containers are the objects to organize or store various types of data such as vector, comma list or etc. comma it can be comma array, it can be queue, DQ. So the basic, you may say that the basic STL is contained in containers. That's right. But some algorithms can be applied on containers. Like if we want to sort an array, we can directly apply sort function. That sort function will be included by a header file hash include algorithm and iterator is like a position pointers which will point to an element in the container. So these things might look quite messy for you right now, so we will start with a program so that these three things can be easily understood. So now we will move to the programming part. For programming, dev cpp has limitations with the free version that you may have, that you have to include g++ 11 or higher. So I have tried, but I haven't succeeded to work with dev c++. Only vectors can be done with dev c++. So I you can try online compiler, but in this lecture I will use linux based g++ compiler. So we will start here, like g++, sorry, gedit and I name this file like STL or xt1 dot cpp. So the first thing we can include header files, hash include iostream, hash include. Now you already knew arrays, so I will start with the array so that I can directly interrelate with the STL part, because you already most of everybody of you must have known arrays because it has been taught in the previous semester. So I will write here hash include array and using namespace std int main. So here array is an inbuilt class template. In the previous lecture I have explained you the class templates, so you can refer to that one for understanding this array int. So here I have declared object of an array called a, which will contain the template for integer types. So I have written here 1 2 3 4 5 like the normal integer array. So I can, if you want to print an array, what will you do? For int I equals to 0, I less than 5. Sorry, you have to mention its size also. So I have written here size I plus plus here, and here you can write now a dot at, that means at is a member function of which class? Array class. You can write it as like this. Array is a, here array is system defined class in the array STL. So here this array is a container. This array is a container. So we have only implemented array as a container now. So let us run this program. Sorry, it is st1. See, the array gets printed here as a normal. You can also write it as, sorry, you can also write it like this. This will also works because these square brackets are overloaded for the array object. So this is normal array. Now the question is, what is the advantage of array class as a template? So this thing can be made very easily with the normal array also, but because of the its this array STL has inbuilt functions, so we will try to use that functions to show the advantages of these kinds of array STLs. Let us suppose I have array int b is equal to 6, 7, 8, 9 and 10. We have to mention size also. So I have size also. Now to see the advantages of this array STL, we will try to swap swap both these type of array. So we should have handle here, clear, and now I will use a dot swap and return b. So that means swap is a member function of array class. Now after swapping I will print both these array. So I'll print cout after swapping values of a is equal to, so we have to erase this. Clear. Now we will try to run this function, and then so here the values of a are 1, 2, 3, 4, 5 that we have input, and values of b are 6, 7, 8, 9, 10. And after swapping, values of a become 6, 7, 8, 9, 10, and values of b become 1, 2, 3, 4, 5. That means we do not have to write the complete program, just we have to call the inbuilt library function swap, and we complete it, or we achieve the purpose of swapping of two arrays. Otherwise we have to write minimum 5 to 10 lines more for swapping the both of these arrays. So this is the advantage of STL, that we can use the functions directly from the library. But here we have used only container. Now what is the next part? The next part was algorithms. So what are algorithms? These process data in containers. Like here, there are different algorithms mentioned here. We will use only sort in this lecture for demonstrating algorithms, the sort function. So let us again go to the compiler. Now here we have, let us suppose we have this array. Okay, but this array is already sorted, so we just try to mix the numbers in unsorted manner. Okay, so we now want to sort this array with the help of algorithm. So we have to include the library for algorithm, and here now we want to sort this array. Okay, now for sorting this array we will be using sort member function. So what are the parameters for the sort member function? So now we want to use this sort member function. So let us clear what are the parameters for the sort member function. The first argument will be the starting address of the array, and the second argument will be the ending address of the array. So there are inbuilt functions for the starting address and for the ending address for this array STL. Let us suppose I write cout a dot begin. Okay, and handle a dot end. These are the two inbuilt functions whose value I have printed now. So let us try that. To try to run that, see, we got two addresses. This is the starting address and this is the ending address for this array, and we now will pass this starting and ending address to the sort function, which will be used as an algorithm to the container, which will be applied on the container array here. Now what is an algorithm? This will ease our work for sorting the array. Here we will only write a dot begin, a dot end, and just close that. Now for printing the array we will write for int I equals to 0, I less than 5, I plus plus cout. You can write a at I, or you can use scare brackets and skip the add function. So, sorry, I have not used handle, so the result is not clear. Here we should use handle, and then we should run this. See, after sorting, this array values gets sorted. So this is the utility, and now we have learned the second concept, that is called algorithm. Now what is the third point? The third point is iterators. Iterators are the basically position pointers which will point to the element in the container. So where we have used iterators until now? In for loops, like in the previous program also we have used. Here we can say I is an iterator, but there is a another mechanism where iterators are used in different manner for STL. Why they are used in different manner, not like these iterators? Because that will fit into any kind of STLs. We will be having a small discussion when we are using vectors, where we can do one thing with the STL iterators, not that can be possible with these kinds of integer kind of things. So we will see that in a vectors portion only, but here we will learn how to implement iterators in array. So what is the syntax? Syntax is same. You will have to write a int iterator I. So here we have declared I as an iterator. Okay. So now if we want to use I for I is equal to a dot begin. So what will be the value of a dot begin? It will have the starting address of array. Then I not equals to a dot end. So what does this sentence means? A dot end. A dot end will contain the ending address of the array, and then we can use I plus plus. Now for printing, what we should use here? If we write here a dot ati, what will happen? I is not the position here, because I will contain the address, it will not contain 0. So we can directly write pointer of I, because I contains value in which ways? In the address form, beginning address to the ending address, and I will increment that portion. So let us run this program also. What is the error? Sorry, we have not used the class template properly. Why? Because here we have to pass size also. So what is the problem there? There is the problem with this one is that we have to use array here. Means the syntax I have written earlier a int comma 5, but the correct syntax is we have to use the array because this iterator is used for array for generic type, not for a. So array int comma 5 iterator I, this is the syntax. Now we will see whether it works or not. Just we have to use handle here, and what can we do? We will run this and the values gets printed. So that's all about the arrays. Now our actual thing that is in the syllabus will start, that are called vectors. Now what are vectors? Vectors are nothing but it's a dynamic array with a size flexibility and direct access to any element. So difference between array and vector is that with arrays we don't have size flexibility. With vectors we have size flexibility. So what do you mean by size flexibility? Let us suppose we want to declare an array. What we will do, we have to declare size also. Like in the previous program we have clearly mentioned that size of array is 5, but with vectors, dynamic arrays are possible. What do you mean by dynamic arrays? Like, we do not need to specify how many elements an array want to store. The moment we insert an array element to the array, it will show that we have that its size is has been increased. So we will check that what is this dynamic array, and this direct access to any element means if you want to directly access seventh element, you can directly access that. But for this dynamic array we have to show the concepts of size and capacity, and but first we will learn about the header files. Sorry, gedit. So here we can replace array with vector. Now if I want to declare vector, I need not to specify here its size. I can directly say okay. Now I can simply type here. Let me comment this portion. I will use this portion later. Now cout v dot size. Okay, and then cout capacity. we will also write and else our output does not mess up. Clear? Now here I want to insert what is size, what is capacity. Size is elements in an vector which is dynamic array, and capacity is total space which can be which is dedicated to that vector. So size is number of elements in that vector, and capacity is total number of memory spaces allocated to that vector. So I will clear with the out these two terms with the output also. So here I have write v dot pushback. Pushback is a member function for vector class which can be used to insert an element. So I have written 7 and then again, and next element is 6, and next element is 9, and next element is 2, and then we can check the its size and capacity. So here when we have declared we have not inserted any element. So its size will be 0, its capacity will be 0. When we have inserted 7, then its size will be 1 and its capacity will be 1. Please note that capacity gets multiplied by 2 whenever it is fully occupied. Now its capacity is 1 and size is 1. So that is occupied by element 7, that one the capacity that it has. So whenever this element we want to insert, next element is 6. So here its capacity becomes 2 times. So here when the line goes to here, see out size is equal to size will be 2, capacity will be multiplied by 2, that is also 2. Third element gets in, then size is 3, but here the capacity is 4 because it will get multiplied by 2. Here the size is, when you insert the this two element, the size is 4, and capacity, what will be the capacity? Capacity will also be 4 because the capacity was not completely filled. So if I write here one element, if I push one element more here, and I write here 5, so what will be the size? Size will be equal to number of elements. Total number of elements is 5, but the previous capacity was 4. So the fifth element comes, but its capacity is full. So it will increase its capacity by the multiplication of 2. So capacity will be 8 and size will be 4. Oh, sorry, 5. Let us check by executing this program. What does this program means? That size and capacity are dynamic. When you insert an elements, automatically its size and capacity increases. But you do not need to specify at the beginning of or at the declaration of vector. So this is major advantage of vector over arrays. Let us run this program. So why this? Yeah, push underscore back. It should be push underscore back. I have written here everywhere. It should be push underscore back. See here, at the starting size is equal to 0, capacity is equal to 0. Then size equals to 1. When first element comes, capacity becomes 1. Size becomes 2. Capacity is multiply of previous because its previous capacity is 1 and it is fully occupied, so it's at multiplied by 2. Then size is third element comes, capacity was 2, so it is to be multiplied by 2. So capacity is 4 and size is 3. Then size is equal to 4. What will happen to capacity? Capacity is 4 but it contains 3 elements, so it has space for fourth element, so no need to multiply by 2 here. So it becomes 4. Next fifth element comes and then the capacity will become 8. So this program shows the advantage of vectors over array, that it has dynamic memory, dynamic array, okay, which cannot be achieved by normal arrays or array STL. In normal arrays, dynamic arrays can be made, but that dynamic arrays you have to specify the size. You can write int pointer p is equal to new int square bracket 5. That means you are specifying. You can only delete it, but not reassign it. But with vectors, it is automatically done by the compiler. Like push back, underscore back, there is pop out, so with that you can uh, empty the vector one by one. So I will again go to this program. Now I will erase this part and come to again. Sorry, I have to have this part because their vector was completely empty otherwise, or you can use this as well. Okay, and now here I will make my task easier by only writing a here. So this is the same program which I have made for arrays. Now this same program can be used for vectors. So what is the problem? Oh, I have not change the template part. So I have to go again there because vector does not require size. So I will now what is the error? Oh sorry, I maybe I have not changed here. It should be changed to vector. So you have to take care of one thing, that in arrays you can print the value of a dot begin if you have right here, but in vectors this is not possible. This will give you error. So if I write here, see, so this is error because this is not type compatible with cout. So what we but arrays are. So we will not go to in detail of that one, why it happens to be with, why it gets printed with the array and with not with vectors, because the standards have made like by the developers like this only. So whenever I want to now use this, I can use it same as array, but just delete here and use it same as array. So now it does not show any error. So we will print this. So this get printed and array gets sorted here. So we can use it same as array, the sort function. Sorry, I want to show you one more thing, that is where the things where the normal iterator, any other iterator may get fail, but your these kind of iterators like we have declared vector iterator I here will succeed. Suppose we want to insert at specific position. Now suppose we want to insert at specific position. Let us suppose I have written I is equal to again a dot begin plus 3. Okay, I is a dot begin plus 3 and I want to insert 7 there. Okay, so what will happen? Save it, and so I have not printed the value. So let us print the array again. Okay, so
you can see here 0, 1, 2, 7. Here 7 gets inserted with the help of insert member function. But suppose now we want to use it with normal iterator or normal variable. So because I can say here j is an variable because it does not iterate through the loop. So I just write here 4 and or j comma 7, whatever you want. So here we cannot use it as like that. So there is a basic difference now where the vector iterators are doing our job but the normal variables do not. So our vectors STL is completed. Now the next topic is hashing. So our next topic is hashing. Now hashing is used for faster access and efficient storage. Hashing maps given value to a particular key. This helps in faster access. What does this mean? Let us suppose hx suppose is a function of modulus 10 where the value x is equal to 11, 12, 13, 14, 15 and 1, 2, 3, 4, 5 will be acting as keys. Now with this example I can show you, let us suppose we have here 100 entries, there are 100 entries and we have an hashing function of modulus 10. Please note that this modulus function is only for demonstrating. There are many other efficient hashing algorithms or hashing keys algorithms that are much more efficient than modulus, but this modulus function is only for demonstrating. So with this modulus 10, what I am doing, every value of this is passed through this and the result will be act as an key. Here, like if you divide 1 modulus 10, so how many values will be there? 100 modulus 10 up to the any digit you want to modulus 10. So there will be 10 keys. Like in the previous example, there are only 5 keys for this one. So there are 10 keys from 1 to 0. With the key 1, key number 1, it will store only 1. It is used for faster access. Here, like if I want to search 11 here, how many accesses I need? 11. But here how many accesses I need? One for the key, second here and third here. So it will only need 3 accesses. So let us do smaller programs. Again, this will not work in your dev C++ until or unless you download header files, bits and slash std C++, or you can implement it as in the online compiler. I will implement it in G++ compiler. So again we are editing it, gedit. Look, we need not to include any header files for this because hashing is basically in the standard nowadays hashing is done through maps, but maps are not in our syllabus, so we will simply use the basic program to
demonstrate hashing. So again, it's a template. So we will be having hash int h cout. Let us start with character so that you can understand easier characters. I now want to hash the value of a character. Let us suppose which character I hash the value of. Let us go start with capital A and just write G++ and then you can run this. So we have what we want to do. We wanted to get the hash value of capital A, that is 65. So it will be in most of the compilers will return the ASCII value for the characters. Now edit this program and let us suppose I write string and here I write string value. Okay, so now I can, if I run this program, so see, for hello I have this huge value, that is the hash value for hello, and for the integer component, for positive integers most of the compilers will return the same value. Like I have written 78 here, it will return 78. See, it has returned 78. But if I put negative sign here, it will return hash value for this function. See, the large hash value has come. So this is all about hashing. Now we will move to string part. So our next topic is C++ string. We have used multiple times this string. A string is an inbuilt C++ class that contains a character array but automatically manages it using built-in functions. We cannot say it contains an character array, but with the help of string is a library class. So we have to include hash include string and we can use it. But it does not have capabilities like other template classes. Like we have used vectors can be used for integers as well as characters or you whichever you want. But here strings are generally used for character array types of things. Why we are using strings separately? Because we have the advantages of these many functions. So the second one is length. The spelling there is a spelling mistake here. So this is basic string program which we have already done. No need to explain it further. Here string concatenation means if we have declared string first name equals to John, string last name equals to Doe. Here what is happening?
The plus operator is already overloaded for the string class to concatenate. In character arrays, we have to use concatenate function, but here we don't require. Plus symbol, plus operator is doing our job. Here txt.length will print the size of txt, how many letters or characters does this string contains. Txt0 will, all you know, will contain the first letter. GetLine function we have used multiple times. This is sub str, this is used for substring that will print from the first character to the third character, that will be the substring of this. String 1 dot compare str2, it will compare two strings, in this case string 1 with string 2 to, if they are equal then it will return true, otherwise false. Now what is the meaning of string constant of C++? Like, I will show you. Gedit Now if I want to print this, I requires a loop for int I equals to 0, I less than 5, or whatever number you want, it's 5, and I plus plus, and here cout pointer p, or you can simply write p of I. Now I just want to compile it. So what does I get? What do I get? I get C++ for bits converting a string constant to character pointer. Means these things are created as warning here. So it's a warning. I can run this and print, but it's a warning. Why it's a warning? Because if you are declaring it as a pointer, then you must do it with constant, because this string hello, for the security purpose that nobody tries to manipulate it, its C++ compiler has made it compulsory to have a constant pointer instead. So I can change it to constant character pointer. So now what is the output? No warning. So direct output. Okay, and we can see another cases also where
if I P0 equals to I, and now try to compile it. So we got warning here, and after I run it I get segmentation fault. Why do I get segmentation fault? Because C++ mentioned it as an whenever you want to declare string with the help of character pointer, it should be of constant. So if I change it now to constant, it will get me the error at the time of compilation only, not at the time of execution of the program. Sorry, I have not compiled it. See, so here it's a read-only location, so you cannot change its value. So, but if I declare it as like this only, then it's alright, because oh sorry, I have declared as constant here. I have to remove constant. Now this is alright. See, H is replaced by I, so the program works. So this is all about STL, and our course is now completed.